In this lesson, you are going to learn how to derive the expression for the second moment of what area of a rectangular cross section. Okay, so looking at this figure that I have here, I have a rectangular cross section here. Okay, and then I have drawn it in the 2D form. Okay, so I have the y-axis here, and then I have what the z-axis here. The z-axis is the same as the neutral axis, okay, which is the line that passes through the center of this cross section. Okay, so the actual height of this rectangular cross section is what? H. Okay, so measuring from the centroidal or the neutral axis to the top side of this cross section will give us what? Half of the height, which is what? H over 2. Same thing that's happening here. Okay, by looking at this, we are taking the neutral axis as the reference axis. Okay, so what that means here is that every h value above it will be positive, and then every h value below it will be negative. Okay, so let's take note of that. This b here is the width of the rectangular cross section. So now let's look at how you are going to derive the formula for the second moment of what area for this rectangular cross section. So the formula for the second moment of what area is given as what? I equals what? Area times what? The square of what? The perpendicular distance from the axis of what? Rotation. Okay, so in this case the axis of rotation is the z axis, so I'm going to indicate it here. Okay, so this will be the formula. Okay, so now let's look at what is happening here. So with this rectangular cross section, okay, I'm going to consider it to have very small strips of what? Rectangle in it. Okay, so that's what I have indicated here. So looking at this small rectangle here, okay, we're going to take it as what? The strip that is what? Making up this rectangular cross section here. So what that means is that we can divide this rectangular cross section into these small rectangles here. Okay, and then that will fill up this rectangular cross section to make the whole shape. Okay, so that's what that means here. So it can be like this whole cross section here. Okay, it's made up of these small rectangles. Okay, that's what that means here. So we are going to calculate for the area for this small rectangle that has been drawn with what? The color green here, and then we are going to multiply it by the square of what? Its perpendicular distance, which is what? This y here from the neutral axis. So let's look at how we are going to do this. So the area of this small rectangle here will be what? The breadth times what? The height, and then the breadth is given as what? B, and then the height is what? Dy over here. So the area will be equal to what? B dy. Okay, b dy, and then the perpendicular distance from the z axis will be this y here. Okay, so that will be, you are going to get the second moment of area about the z axis to be equal to what? B dy times what? The square of the perpendicular distance, which will be y squared. Okay, so this is what we have. But now this cross section here is made up of what? Small rectangular strips, okay, like what I have indicated here. Okay, so to get the actual second moment of area for this cross section, we must calculate for what? Each one of these small rectangles here. Okay, so I'm going to calculate for what? Each one of these small rectangles that makes up what? The entire cross section. So to do this, we are going to integrate. Okay, we are going to integrate, and then we are going to integrate from the bottom here to the top. Okay, from the bottom here to the top, and then since we are considering every value below the neutral axis to be negative, okay, from this point here to this point here will be what? Negative h on 2, and then from this point here to this point here will be what? H on 2. So let's take note of this. We are going to integrate from this point here to this point to get the entire second moment of area for this cross section. So let's go ahead and then do this. So I'm going to have the iz to be the integral, okay, of the the second moment of what area, so that would be what ay squared. Okay, ay squared. Now you know the area to be what b dy. Okay, you know the area to be what b dy, so that would be equal to the integral of what b dy times what y squared. Okay, from what minus h over 2 to what h over what 2. Okay, so let's do the integration here. Okay, let's do what the integration here. Okay, so now this b here, okay, this b here is just a constant, so I can bring it to this side here. Okay, so when I do this, I'm going to have b integral of what, that's integral from what minus h over 2 to what h over 2 y squared dy. Okay, this is what we have now. Okay, let's continue here. Okay, so we have iz to be equal to the integral from minus h over 2 to what h over 2. Okay, let's not forget the b, then y squared dy. Okay, so this will be equal to b. Okay, and then you take the integral of what y squared, and that would be what y to the power 3 divided by what 3, and then you bring the limit. Okay, that's what from minus h over 2 to what h over 2. So we are done with what the integration. So all we have to do is to substitute the limit into this expression here, okay, to get the total second moment of area for this rectangular cross section. So let's go ahead and then do this. I'm going to free up some space so that we continue. Okay, so now let's continue. So we are going to have the second moment of area to be equal to b. Okay, that will be b y to the power 3 divided by 3. Okay, and then we have the limit here from minus h over 2 to what h over what 2. So what we are going to do is to substitute the value of what h over 2 in place of what y. So let's look at that. So we are going to have iz to be equal to, so I have b, okay, into brackets h over 2 to the power 3. Okay, so this divided by 3. Okay, let me put this in a square bracket. Okay, so let me put this in this bracket here, and then we are going to do same for the second limit. So that was minus. Okay, then let me bring another square bracket here. Okay, let me bring this square bracket here. Okay, so let's continue. So that will be b times what minus h over 2, okay, to the power 3. Okay, and then divided by 3. Okay, divided by 3. Let me write it this way. Okay, it shouldn't confuse you. It's the same thing that I have over here. Okay, just that I wrote the division sign this way. Okay, so let's continue. Okay, so from here we're going to have this to be equal to b h to the power 3 will be what h to the power 3. Okay, that what I have h to the power 3 here. Okay, divided by 2 to the power 3, that gives us what 8. Okay, so this is divided by 3. Okay, let me put this in the bracket here. Okay, minus, we're going to do same here. Okay, b, and then we have what minus h to the power 3, that will be what minus b h to the power 3, and then divided by 2 to the power 3, that give me 8. Okay, so all this divided by what 3. Okay, so this is what we have now. Okay, so now let's go ahead and then simplify this. Okay, so I'm going to have iz to be equal to, this will be bh cube over 8, okay, times what 1 over 3. Okay, minus minus, so that be what plus bh cube over 8 times what 1 over 3. Okay, this is what we have now. So let's simplify that to get our answer. Okay, so let me free up some space here. Okay, so now let's continue. Okay, so now I'm going to simplify this. Okay, so I'm going to have this to be equal to bh cube divided by what? H times 3. Okay, sorry, 8 times 3. That would be 24. Okay, plus bh cube divided by what? 24. Okay, so when I add these two values, you are going to have bh cube divided by what? 12. Okay, so this will be the formula for the second moment of area for what? A rectangular cross section. So that's what Iz equals bh cube divided by 12. So that's all for this video. Thank you very much for watching. Please, if this lesson helped you, please make sure you subscribe and then turn on the notification bell, and also share it with your friends. Thank you very much.